Let us take next topic in module 5, that is numerical integration. In this topic we find the integral of this type using numerical techniques. Let us see the first technique, that is Simpson's 1/3 rule. So this is the formula for this technique, that is h divided by 3 y naught plus yn 4 into y1 plus y3 plus and so on. So that is take all odd numbers here. Can you observe? Y1, that is 1, 3, then next will be 5, 7 and so on till the end, plus 2 into even numbers, see, 2, y4 and so on till the end. And here we have taken first value of y and the last value of y. So in this way we can write the formula for Simpson's 1/3 rule. Next technique is Simpson's 3/8 rule. Let us see the formula here. Here what is the change? Here we have 3h by 8, first value plus last value, 3 into, here you just observe how we have taken continuously 1 2, then 3 is missing, 4 5, 6 will be missing, then 7 8, 9 will be missing. That is the multiples of 3 are missing here. In this term multiples of 3 are missing. Those multiples of 3 whatever here missing will be taken here. See, 3, y3, y6 and so on. So this is the formula for Simpson's 3/8 rule. Next is Weddell's rule. This is the formula in general. Now let us see the formula when n is 6. In particular we have this formula when n is 6. We need to remember. See here, what is the coefficient? 1. The coefficient is 5, 1, 6, 1, 5, 1. See how it is? 1, 5, 1, 6, 1, 5, 1. So in this way you can remember Weddell's rule formula. The following is a common step for applying any of the rule. Now let us see when to apply which rule. Which rule we should apply and when. And how do we apply? Interval is divided it into n equal parts of width h. So h will be calculated using this formula: upper limit minus lower limit, that is upper limit minus lower limit of the interval divided by n. So the interval is here, b minus a divided by h we do, sorry, divided by n we do. Suppose these are the values you get after dividing into n equal parts. This is the first value of x, that is we have taken x naught as the first value, that is a. Next value then next value, and so on. So for these values of x, we can find out the values of y respectively and call it as y0, y1, and so on. Then we can apply the respective formula based on the n here. If we tabulate the found values of x and y, found values of x and y like this, we form a table of x values and y values. There is one note: when we divide the interval into n equal parts, so how many values you will get, how many values of x you will get when you divide the interval into n equal parts, how many values of x? Yes, it is n plus 1 values of x you will get. See, here is one part, here is another part, here is another part, and so on. You will get finally n parts. So in these n parts, how many values of x you can find? You can find n minus 1 values of x, that is n here, plus one more value, that is n plus 1 values you can find. So we can conclude that if there are n plus 1 ordinates in the given data, there must be n equal divisions. It is very important to know that to apply Simpson's one-third rule. So when we apply Simpson's one-third rule, if n is a multiple of 2, remember this. To apply Simpson's 3/8 rule, n must be a multiple of 3. So if you want to apply Simpson's 3/8, n must be a multiple of 3. To apply Vidal's rule, n must be a multiple of 6. So multiple of 2, Simpson's one-third, multiple of 3, Simpson's 3/8, multiple of 6, Vidal's rule. So you remember. Thus, see, one more observation: when n is a multiple of 6, it will be a multiple of 2 as well as it will be a multiple of 3. So when n is a multiple of 6, you can apply any of the three methods. That's what yeah, step-by-step working procedure for problems. So in the first step, given the integral will be given. First divide the interval into appropriate number of equal strips so as to apply the desired rule. Okay, we will divide into equal number of equal parts, in number of equal parts. In the second step, for all these values of x, we find the values of y by using the function under the integral. Whatever function is there under the integral, we treat that as y and we evaluate the values of y for these values of x, So we find the values of y in the second step. Third step is substitute values from this table into appropriate rule to obtain the approximate value of the given definite integral. So these are the main steps here we have. Sometimes it is possible to deduce the value of certain quantity by equating the theoretical value of the definite integral. We will see this note while solving the problems. Now let us consider one problem. The question is evaluate this integral dividing the interval into 6 equal parts by applying all these they are asked. So what is n here? N is 6 because we are dividing it into 6 equal parts. So this n is a multiple of 6. As I said, when n is a multiple of 6, you can apply any of the three methods, any of the three. So that's why they are asking to solve this problem using all three. Let us go for the solution. Yeah, first step is divide this interval into 6 equal parts. To do this, first we need to find the value of h. The value of h. How do we find the value of h? Is upper limit minus lower limit divided by n. Now let us do that. That's what we have done here. That is 6 minus 0, that is b minus a, divided by n. N is 6. Where is n? N is here. So the 6 we have taken in the denominator here. If they give 12 here, if they give 12, we take 12 in the denominator in the place of n. So what is n h now? That is 6 by 6, which is equal to 1. So we got the value of h as 1. So using this value of h, you can find the values of x one by one. Let us start with this 0. First value will be 0 because starting value is 0. We consider this 0 as x naught. The first value is 0 we have taken. And how do you locate the next value? If you add the value of h to the 0, you will get the next value. So what is 0 plus 1? 1. We got the next value. Then how do you find the next value? Simple. Add the value of h to this value, we'll get the next value. That is 1 plus 1, 2. Similarly, add 1 to this 2, you'll get the next 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. So we need to stop here because we reached the end here. The last value is 6, so we reached here and stop the process. Now, as I said, we need to find the values of y corresponding to these values of x. So where is our y? Y is here under the integral. So we consider this as the value of y. We have considered the value of y as 3x square. Let us put here the values of x. We formed a table, the values of x here, and we find the values of y in this row. When you put x is equal to 0, or there are here x is equal to 0, y is 0. When you put x is equal to 1, y is, yes, the value of y will be 3. When you put x is equal to 2 in this y value, what you get? You get 12. And go on naming this value of y as y naught, this as y1, this as y2, and the value still y6. So we got all the values of x and all the values of y which are required in the formula. Now one by one we apply all these formulae. First formula is Simpson's one-third rule. So this is the general formula. Now let us rewrite this general formula for n is equal to 6. N is equal to 6. So how do we write? See here, we have written this integral as the given integral. This integral is given in the question, where a is 0, b is 6, and y is 3x square. So next, what we have written 1 in the place of h, because h is 1. Then first value plus last value in the table of y naught plus y6, because y6 is the last value, plus 4 into. So how do we write this? You take all odd integers till the end. There is y1 plus y3 plus y5, y1, y3, y5. Now what? Can we take plus y7? Can we take plus y7? No, because y6 is the end point. We cannot go beyond y6. We cannot go beyond y6. So we need to stop here and close the bracket. Plus 2 into all even numbers here. Start from 2. That is 4. Next what? y6. But y6 is already used here. So you cannot write y6 also there. So stop here and close the bracket. We have all the values of y in the table, and substitute those values. You will get the answer of the integral as 216. Now let us similarly we can find out Simpson's 3/8 rule. Here is the formula. H in the place of h we have taken 1. So we got only 3/8 y naught plus y6 plus 3 into, how do we write? 1, 1, 2, 4, 5, and so on. That is, except multiples of 3, we write all values except multiples of 3. We have to stop here. You cannot take y7 because y6 is the last value. You cannot continue. So stop here and close the bracket. Plus 2 into all multiples of 3 will be taken now. So how many multiples of 3 are missing here? Is only 3. Only y3 is missing. You cannot take y6 here because y6 is already used there. Y3, you cannot take y6 because y6 is already used here. Values, you get the same answer. Next is Vital's rule. So this is the formula you need to remember. Similarly, put the value of h as 1 and put all the values from the table. You will get this answer. So this is a very simple procedure to evaluate the given integral using using numerical techniques. So this completes the problem.